proper subset. Set A is a proper subset of set B, symbolized by A is a proper subset of B. It's like a U that's on its side. If and only if all the elements of set A are also elements of set B, and set A and B are not equal to each other. So you say to yourself, hey, that definition sounds a lot like subset. Well, you're exactly correct. It is, except it has that second little criteria there, is that the two sets cannot be equal. And you'll see the equal sign with a line through it. That's what that means. So again, set A is a proper subset of set B if and only if all the elements of set A are also in set B, and set A and set B cannot be equal to one another. So let's do an example to make more sense. So here we're given set A that has the elements 6 and 7. Set B has the elements 5, 6, 7, and 8. And we want to know if set A is a proper subset of set B. So let's see, are all the elements in A, which are 6 and 7, are they in B? Yes, 6 and 7 are in B as well. Are the two sets equal to one another? No, they're not equal. They don't have the same exact number and members in the set. So this is an example of what we would call a proper subset. So set A would be a proper subset of set B, and the proof of that, those two things: number one, all the elements of set A are also elements of set B, and then the second criteria is that set A and set B cannot be equal to one another. So let's go over real quick the difference between a subset and a proper subset, because their definitions are very, very similar, except one has one more criteria than the other. So a subset, recall, is every element of set A is also an element of set B. And it is the symbol with the side U, but with a line underneath it. Now, set A and set B, it's okay if they're equal to one another. That's not a problem with subset. Now, let's look at proper subset. Now, the definition is still the same of all the elements of set A are also an element of set B. Now, the symbol itself looks similar, except it doesn't have the line underneath it. And the other with the criteria with the proper subsets is that the sets cannot be equal to one another. Okay? So again, as far as the definition, set A, every element of set A is also an element of set B. That's the definition for both. All the elements of set A are also an element of set B. The symbols look pretty much the same, except a subset has a line underneath it. So you can think of like a submarine underneath. A line is underneath, versus a proper subset doesn't have the line underneath. Now, in terms of the difference in criteria with subsets, it's okay if the sets are equal to one another, but they cannot be equal to one another with a proper subset. And there you have it.